Hi everyone, it's Mrs. H. Today we're going to talk about 8.5, which is the remainder and factor theorems. Doing a little bit of our work with long division and synthetic division has led us into this point, but let's start and see how they link together. All right, so question number 1 here. This is an old question. We talked about our function notation way at the beginning of the year. And remember that this function notation here really just means plug in 3 for x and see what you get. So I did all that work already to save some time. We're going to do something that feels a little bit different, and then we're going to see how they're linked together. We are going to divide our polynomial over on the left there by x minus 3. I'm going to use synthetic division. So I'm going to have 2, -7, 6, and -3. In my box is going to be 3. And I'll just go through my steps here. Bring down my 2, multiply, add, multiply, add, multiply, and add. And I get my remainder. Now, as I look at this, I notice something, and that's my answer over on the left here is the same as my remainder. This is actually always going to be true, and this is our remainder theorem. The value of our polynomial, i.e. when you plug in some number, is equal to the remainder from, it says synthetic division. You can also, of course, do long division. We know that they are basically equivalent. Synthetic substitution is when we're going to put this together to find that actual number. So I'm going to skip step A over on the side here, and we're just going to use step B to evaluate some polynomials. All right, so let's do a couple and see what happens. Why don't we start with number 2 here? And I'm going to use synthetic substitution to find P of 2. If P of 2, the value of P of 2, that is going to be the same as when I divide this polynomial by x minus 2. So 2 is already your answer when you set that equal to 0. All right, so let's do that. I have 1, -3, 1, -1, and in my box goes my just 2. It's just the same as your number you're plugging in. I'm going to go through my synthetic division here. I have 1, 2, -1, -2, -1, -2, and my remainder here is -3. So I know 2 things. I know this division problem, I shouldn't have erased it there, is equal to, oh, well, let's see, I know the whole thing. It would be x squared minus x minus 1 minus 3 over x minus 2. But what this work also tells me is that when I plug in 2, I get -3. You could, of course, check this because I could easily do 2 cubed minus 3 times 2 squared plus 2 minus 1. When I do all that out, I do, in fact, get -3. All right, let's do number 4 over on the side here as well. When I want to have a negative, that's fine. I'm still just going to set up with 1, 2, -1, and 4. In my box is exactly that value, so -5. I go through my algorithm, which is so quick once you get used to it. 5 times 14, well, 5 times 15 is going to be 75, so I get -70. And then that's going to give me a remainder of -66. So what is the value of this polynomial at -5? It is -66. All right, 2 more. Let's do a question here. Is x minus 2 a factor of this polynomial? We did one of these with our synthetic division. If this is true, what does this mean? This means that my remainder is going to equal 0. So let's test that. Does my remainder equal 0? I'll set up my synthetic division. I have 1, -4, 5, 4, -12. In my box, I'm going to have 2. And let's see. pull down my 1, multiply, add, multiply, add, multiply, add, multiply. Oh, hey, look, I got a value of 0, which means that this does divide in evenly. Yes, this is a factor. What I could say, well, the answer to this question is yes, but I also could say that x minus 2 times x cubed minus 2x squared plus x plus 6 is equal to my original p of x. Were I to distribute that all out, it would in fact work. And we're going to see a little bit more of this as we move on in the chapter. We're going to do a little bit more kind of writing it like that. All right, one more before we just finish up with our last topic. Is x plus 1 a factor? Well, this one, we just did this, so it's going to be set up the same way. My remainder is going to be equal to 0 here. All right, let me start setting it up. I have 1x to the 12th. I have no x to the 11th, none to the 10th, none to the 9th. Oh my goodness. How many zeros am I going to have here? I do not want to do all that work. Synthetic substitution is just too much. Now it works to check it, but it's a whole lot of zeros. I don't really want to keep track and make sure I'm writing them all out. But we know a couple of things here. We know that the value when I plug in -1 is equal to the remainder, because that's what we just said our remainder theorem was from up above. And so if the value when I plug in -1 is 0, then the answer is going to be yes, this is a factor. That is a lot quicker than doing out my synthetic substitution. So what I'm going to do instead is I'm going to just plug in -1. That's going to give me -1 to the 12th minus 3 times -1 to the 8th minus 4 times -1 minus 2. This is going to give me 1. That's a positive 1, so I get minus 3. That becomes a plus 4. This is a minus 2. Let's see. I have 1 and 4 is 5. Minus 3 and 2 is 5. That does give me 0. That means my remainder is going to be 0. So my answer to this question is going to be yes. That is, in fact, a factor. All right, one more theorem here. Our factor theorem, the polynomial p of x has x minus some number r as a factor if and only if r is a root of the equation p of x equals 0. I was a little bit loose with my vocab when I said root in our last chapter because I kind of said it whether we had a remainder or not. But this is telling us that it's a factor if the root is actually that. If when I plug in 0 for y, I get that as an answer. Remember from geometry, this if and only if works both ways. So if I know that this is a factor, then I know that it's a root of the equation when I equal 0. The other way around also works. If it's a root of the equation p of x equals 0, then I know x minus r is a factor. All right, so we can use that both ways. Let's do out a couple more problems here. Whoops, sorry about that. Let's do, I think, maybe 3 more. And let's start with number 6 here. Find a polynomial equation that has integral coefficients. So remember, this means no fractions. And we have 3 roots. We're going to have roots of 1, -3/2, and 2. What do I know about this? Well, there's a couple of different things I can do here. I cannot do my sum and product anymore. That only works for quadratics. So what I could do is just say that each of these is going to give me a binomial. So I'm going to have x minus 1 to give me that root of 1. I'm going to have x plus 3/2 to give me that root of -3/2. I'm going to have x minus 2. I could go ahead and multiply these all out. What I might do is multiply this one and this one first. I'll have x plus 3 halves, and then I'm going to have x squared minus 3x plus 2, and then I could distribute. When I distribute, I'm kind of pretending like for a moment this says equals 0. And so I can really do anything that I want here as I'm writing my equation, as I'm writing my polynomial equation. I'm going to decide to get rid of those fractions first, because yuck, I do not want to deal with having to multiply 3 halves times everything. So why don't I just throw a 2 out in front? And if I multiply both sides here by 2, well, this doesn't matter. And this 2, I'm going to choose to distribute into that factor. All right, so now I'm going to actually distribute 2x plus 3 into x squared minus 3x plus 2. I'm going to spare you the details. I'm just going to tell you the answer here. You do get 2x cubed minus 3x squared minus 5x plus 6. This way always works. However, there is a shortcut that we can take. I know that it was not that difficult to multiply those two binomials, but what happened when I multiplied those two? I just immediately got my quadratic here. So I could have immediately chosen to do my sum and product with those ones. My sum of 1 and 2 is going to give me 3. My product is going to give me 2. Oh, well, then I have that one loner root. That's going to be my x plus 3 over 2. But I know my sum and product rule, and it jumps right away to minus 3x plus 2 like that. These are little arrows, not negatives. All right, it skips a minor step of work. All of the work after that is the same. They do end up being the same, so it doesn't matter which way you choose to go about this. All right, 2 more questions. Let's do number 7 here. Solve the equation given the indicated root. They are telling me that this is a root, and so I can divide it out. I'm going to use that synthetic division to divide out my root. I have 1, -2, -1, 2, and I'm taking out my root of -1. When they tell you the root, they're already setting it equal to 0, so it's just a -1 in my box. I better get 0 as a remainder because they told me it's a root. So let's see. I'm going to have -3. I'm going to have 3. That's going to give me 2, and that's going to be good. Okay, good. I got 0 as a remainder. Remember what this means. This means that my equation is now factored as x plus 1 times x squared minus 3x plus 2. They asked me to solve this. This is equal to 0. Well, hey, guess what? We're back to quadratics, and I know how to factor that. When I factor that, I'm going to have x plus 1. We already knew that root. And then I'm going to set up my binomial, and I'm going to factor. This factoring is not bad at all. It's going to be -2 and -1, and this is going to give me 3 answers. I already knew that first answer. Don't forget to include it. I then found out about 2 and 1 as well. Number 8 is very similar to this. They give you one of your roots, and then you keep solving after. It just doesn't work out quite as nice. So sorry, I left you the messy one. One more problem. Let's do number 9. I want to find m such that -2 will be a 0 of this equation. Remember, 0 just means a root. This just means that my remainder is going to be equal to 0. All right, so I'm going to set it up. I have 1, 3, -7, and m. And -2 is going to be my root. So I'm going to drop down my 1, my -2, my 1, my -2, my -9. That's going to give me 18. However you write this, you could write your 0 here and then deal with your whole thing. You could write your m plus 18 there and know that it has to equal 0. Either way, we get the same answer. It's just semantics, how you write it. My value of m is going to be negative 18. All right, one last hint that I'll give you on number 10. Oh my gosh, x to the 97th. Do not use synthetic, you know what? Let's just do it. Do not use synthetic division. It takes way too long. We're going to use the factor theorem. If this is a factor, that means that -1 is going to be a root. Well, if -1 is a root, that means that my remainder is going to be 0, i.e. the function, I don't know what it is, when I plug in -1 is going to be equal to 0. So let's do that. -1 to the 97th plus m times -1 minus 5, that better be equal to 0. -1 to the 97th is just -1 minus m minus 5 is equal to 0. I got negative m is equal to 6, so m must be -6. There we go. We've got our answer. All right, I did an extra problem there, but hopefully all of that makes sense. There is one more that you are welcome to try, number 8 there. I'll post these with the answers. Good luck. Please let me know if you have any questions.